right, I hope you guys had a restful spring break, but we're back to making math videos about finding the solution set of absolute value equations. Remember that we are trying to get the absolute value bars isolated before we solve the problem with the two separate equations. So you have to do algebra before you do the algebra. So let's take a look at problem number 1. The original problem is going to be in blue. So we have 3 times the absolute value of x minus 2 minus 7 is equal to 53. So first things first, you can't split it into 2 equations until you get the bars isolated. So what I'm going to do is I'm going to put a highlighter on the expression with the bars. So it's much easier to solve if you have it in highlighter, in my opinion. If it's fine with you in pencil, that's totally doable. So remember that we're solving for x. But in order to solve for x, I'm going to do algebra before algebra. So think about this like 3 yellow minus 7 is equal to 53. So think about it, instead of like solving for x, let's just pretend, you know, it's yellow. So 3 times yellow minus 7. I need to undo the layers of yellow to solve for yellow. So I'm going to add 7 on both sides. And now I'm left with 3 times the bars is equal to 60. So 3 times the absolute value of x minus 2. I'm going to put that in yellow. So now I've got 3 times yellow is equal to 60. How do I get yellow isolated? I'm going to divide both sides of the equation by 3. So remember, this is the absolute value of x minus 2. So I've got 3 times the absolute value of x minus 2 is equal to 60. I'm going to divide both sides of the equation by 3. And now I'm left with the absolute value of x minus 2 is equal to 60 minus 60 divided by 3 is 20. So now I finally got the bars isolated. Is this problem solvable? Yes, because the bars equal a positive output. So what that means is I take the inside and I'm going to split it into 2 cases. So either x minus 2 equals 20, or x minus 2 equals negative 20. So now I have to account for forwards and I have to account for backwards. So let's solve for the right equation first. I'm going to undo the layer of x by adding 2 on both sides. That cancels out, leaving me with x is equal to positive 22. But that's not the only solution. I'm going to go to the backwards equation, and I'm still going to apply add 2 on both sides. And that leaves me with x is equal to negative 18. And now I'm going to check my work by plugging in x equals 22 or x equals negative 18. Let's plug in 22. So if I plug in 22 in for x, 22 minus 2 is 20. The absolute value of 20 is 20. 3 times 20 is 60. 60 minus 7 is 53. Therefore, x equals 22, you're good. Let's plug in x equals negative 18. Negative 18 goes in for x. Negative 18 minus 2 is negative 20. But then the absolute value of negative 20 is also positive 20. So then 3 times 20 is 60. 60 minus 7 is 53. Therefore, x is also allowed to be negative 18. It's that simple. All you need to do is get the bars isolated first. So do algebra before algebra. Now that the bars are isolated, see if the problem's solvable. If it's solvable, split it into two equations. And solve for x on both. Okay. Number 2. The absolute value of 5x plus 2 plus 7 is equal to 10. So first things first, if I see those absolute value bars, I want to get them isolated first. So I'm going to apply my highlighter on them. So let me just do that really quick. Sorry about that. You'll see what I'm going to do later, okay? All right, so remember, we've got the absolute value plus 7 is equal to 10. Well, I can't make any judgments yet until I get the bars isolated. So if I have yellow plus 7 is equal to 10, how do I solve for yellow? I'm going to subtract 7 from both sides. And now I've got the absolute value of 5x plus 2 is equal to 3. And now I look at this and go, is this problem solvable? Sorry, I think I wrote it twice by mistake, but is the absolute value of 5x minus 2 solvable if it's equal to 3? Yes. So I'm going to take the inside and split it into two equations. Either 5x plus 2 is equal to positive 3, or 5x plus 2 is equal to negative 3. So let's start with the right side since I'm a positive person. So I'm going to solve for x. I've got 5x plus 2 is equal to 3. I'm going to undo the outer layer by subtracting 2 from both sides. So I'm left with 5x is equal to positive 1. And now 5x is equal to 1, so I'm going to divide both sides of the equation by 5. I'm okay with you leaving this as a fraction 1/5. But if you're on team decimal, if you do 1 divided by 5 in the calculator, you get 0.2. Either way, acknowledge that 1/5 and 0.2 are the exact same value. Okay, let's take a look at the other side. I've got 5x plus 2 is equal to negative 3, so I'm going to subtract 2 from both sides yet again. And so I get 5x is equal to, what's negative 3 minus 2? That would be negative 5. And now I need to undo that final layer on x by dividing both sides of the equation by 5, leaving me with x is equal to negative 1. So let's plug them into, sorry, let me put a big old or. So either x is equal to negative 1 or positive 1/5. Okay? Or either x is equal to negative 1 or 0.2. So let's plug them both into the original problem. So let's plug in 1/5. Well, 1/5 is the reciprocal of 5. So basically, if x is equal to 1/5, 5 times 1/5, that would be 1. 5 times 1/5 would be 1. 1 plus 2 is 3. The absolute value of 3 is 3. 3 plus 7 is in fact 10. So this side checks out. Let's plug in x equals negative 1 now. 5 times negative 1 is negative 5. Negative 5 plus 2 is negative 3. The absolute value of negative 3 is 3. And then 3 plus 7 is 10. So that's how you check your work. Okay, now let's move on to problem number 3. I think I think if you understand the highlighter in the first step, you're good. So remember, we've got 4 times the absolute value of 2x plus 1 minus 6 is equal to 30. I'm going to put a highlighter right here. Pause the video if you think you can do this problem independently, and then you will check our work. Remember, it's 4 times the absolute value 2x plus 1 minus 6 is equal to 30. Okay, so I'm going to do this problem like I normally would. I'm going to keep an eye on the highlighter. So I'm going to solve for yellow before I solve for x. For yellow, minus 6 is equal to 30. Okay, so if I'm solving for yellow, I'm going to add 6 on both sides. No problem. So now I've got 4 times the absolute value of 2x plus 1 is equal to 36. Well, now, if I've got 4 times the absolute value, is the absolute value isolated? No, it's not isolated. So what I need to do is get the yellow highlighted part isolated, or the absolute value bars isolated. So I need to divide both sides of the equation by 4 so that the bars can finally be isolated. So if I divide both sides of the equation by 4, now the absolute value bars are isolated. So now I get the absolute value of 2x plus 1 is equal to 9. Is this problem solvable? Yes, the bars are isolated. It equals a positive output, so I'm going to split this into 2 separate equations. So 2x plus 1 is equal to positive 9, or 2x plus 1 is equal to negative 9. Now let's solve for x. So how do I undo the layers and solve for x? I'm going to subtract 1 from both sides, leaving me with 2x is equal to 9 minus 1. That results in positive 8. 2x is equal to positive 8. So I need to undo the layer of x by dividing both sides by 2. And that gets x finally isolated for one of the solutions. X is equal to 4. Now, we have to do the same layers and undoing for 2x plus 1 is equal to negative 9. So I'm going to subtract 1 from both sides. And now I've got 2x is equal to negative 10. And now 2x equals negative 10 means I need to isolate x by dividing both sides of the equation by 2. Negative 10 divided by 2 is negative 5. So I can either have x equal to positive 4 or negative 5. Now let's plug them in. So let's plug in one of the solutions. Let's go with positive 4. 2 times positive 4 is 8. 8 plus 1 is 9. The absolute value of 9 is 9. 4 times 9 is 36. 36 minus 6 is in fact 30. Let's plug in negative 5. 2 times negative 5 is negative 10. Negative 10 plus 1 is negative 9. The absolute value of negative 9 is 9, positive 9. 4 times positive 9 is 36. 36 minus 6 is in fact 30. So there are 2 ways of getting the exact same output. Okay, turn it around. Let's see if we can do this problem. The absolute value of 7x plus 3 plus 12 is equal to 8. So are the bars isolated? No, the bars are not isolated. So I'm going to see what I can do to get the bars isolated. So I'm just going to target it for now. So now I want to get the bars isolated. If this problem is yellow plus 12 is equal to 8, and I need to solve for yellow, so I need to undo the layer by subtracting 12 from both sides. And now I do have the bars isolated. The absolute value of 7x plus 3 And 8 minus 12 is negative 4. Now that I've got the bars isolated, is this problem solvable? I don't care who you are. There's no such thing as negative distance. The absolute value bars can never generate a negative. There's no such thing as negative distance. So I don't care what's on the inside. This problem cannot be solved. So X has no solution in this problem. Isn't that awesome? If you get the bars isolated and the bars equal a negative output, that means that this problem is impossible to solve. Let's see what we can do for number 5. Once again, are the bars isolated? No. So I've got negative 4 times the absolute value of 9x minus 7. So my goal is to get the yellow isolated. Negative 4 yellow. How do I solve for yellow? I'm going to divide both sides of the equation by negative 4. And now I get the absolute value of 9x minus 7 is equal to 60 divided by negative 4, that is negative 15. Is this problem solvable? No. The absolute value bars can never generate a negative output. Therefore, X has no solution. Okay. All right, let's take a look at the last 3 problems of the day. There's going to be a 6, a 7, and an 8. So number 6 is, a lot of people look at these problems and they go, oh, equals a negative. Easy, no solution. Why would that be the wrong move? I can't repeat this enough. You have to get the bars isolated before you make that judgment call. So for now, this is negative 8 times the absolute value of 12x plus 5. And I'm trying to get the bars isolated. Okay. So since the bars are not isolated, I'm going to try to solve negative 8 yellow and solve for yellow. Divide both sides of the equation by negative 8. And that cancels out, leaving me with the absolute value of 12x plus 5. Negative 56 divided by negative 8 is positive 7. Wow. Is this problem solvable? Yes, it is. Even though the problem started out with negative as the output, but that's because that whole absolute value bar got multiplied by negative 8. Of course, a negative times a positive would be negative. But now, let's take the inside. Since we know that the bars have to generate positive 7, that means that the distance has to be positive 7. Sorry, the distance has to be forward 7 and backward 7. So 12x plus 5 is equal to 7, or 12x plus 5 is equal to negative 7. So now let's solve for x. I'm going to subtract 5 from both sides. And now 12x is equal to 7 minus 5 is 2. And now I'm going to divide both sides by 12. And x is equal to 2 over 12. But what does that mean? I need to reduce this by dividing the top and bottom by 2. So technically, even though if you put 2 out of 12, it's technically correct, please simplify all fractions. It just makes life so much easier. So x is equal to 1/6. Or if you write it as a decimal, I believe it's 0.16 repeating, where the 6 is repeating. It's 0.166666666. Anyway, we're going to do the same old song and dance here. If I subtract 5 from both sides, I get 12x is equal to -12. And if I were to divide both sides of the equation by 12, -12 divided by +12 is -1. So that's how you would do this problem. Okay. Number 7. 6 times the absolute value of x plus 15 minus 32 is equal to -2. Can I automatically say no solution for this problem? No, the bars aren't isolated. So before I solve for x, I got to solve for the bars. So I get my highlighter, and now I'm trying to do 6 yellow minus 32 is equal to -2. So let's get yellow isolated by adding 32 to both sides. So now I've got 6 absolute value of x plus 15 is equal to -2 plus 32 is 30. Okay. And the bars are still not isolated because I've got 6 times the bars. How do I isolate the bars if it's 6 times bars? I have to divide 6 on both sides. So if this was 6 times bars, I'm going to divide both sides of the equation by 6. That cancels out, leaving me with the absolute value of x plus 15. 30 divided by 6 is 5. Is this problem solvable? Yes. So I'm going to take that, split it up into 2 cases. X plus 15 can be broken up into a distance going forwards 5 feet or a distance going backwards 5 feet. Let's solve for x. So if I undo the layer of x by subtracting 15, 5 minus 15 is -10. Okay, all good. And now I have to undo by subtracting 15 from both sides. And so x is also equal to -20. So x can be equal to -20 or -10. Okay, last problem of the day. So -2 times the absolute value of x minus 7 plus 5 is equal to -3. Can I make the judgment call that it's a no solution problem right now? No, I need to get the bars isolated first. So I'm going to highlight it and do my math. And again, I'm making it clear. You don't have to use a highlighter for this. I'm just showing you that you're solving for the bars before you solve for x. So remember, I need to solve the problem. -2 yellow plus 5 is equal to -3, where I need to solve for yellow. So I'm going to subtract the outer layer, -5, on both sides. So that knocks it out, leaving me with -2 times the absolute value of x minus 7, and -3 minus 5 is -8. Are the bars isolated? No. So for the final undo step, I need to divide both sides of the equation by -2. Now I've got the absolute value of x minus 7. Negative 8 divided by negative 2 is positive 4. Is this problem solvable now? Yes. So now I can split this inner equation, this inner expression rather, into two equations. Either x minus 7 equals 4 or x minus 7 equals negative 4. So I'm going to solve for x by adding 7 on both sides. One of the solutions is x is equal to positive 11. I do x minus 7 equals negative 4 on the other side, and I'm going to add 7 on both sides for that. So either x is equal to positive 11 or positive 3. And I know I didn't check my work with the other problem, so I guess I have time, so I'll do it right now. So my two solutions are 11 or 3. Let's plug in 11. 11 minus 7. 11 minus 7 is positive 4. The absolute value of positive 4 is positive 4. Negative 2 times positive 4 is negative 8. And negative 8 plus 5 is negative 3. So that checks out. Let me try the other equation. Let me try the other solution, sorry. X equals 3. 3 minus 7. 3 minus 7 is negative 4. The absolute value of negative 4 is positive 4. Negative 2 times positive 4 is negative 8. And finally, negative 8 plus 5 is negative 3 as well. So we have two ways of getting the exact same output. We're going to do 2 more videos on this, and then we'll have a test. Have a great Monday.